Okay, previously we have done FF14, we're going to FF15. Analyze the results of an experiment using simulations. Now, I'm going to do this again because I wanted to do it like perfectly. One time I did it perfectly, and then one of those parts like thing I didn't like give the full solution. So, enough chit chat. Let's get to it like men and finish strong. Ignore the medals, but let's do this. A farm hires Mitch to test a new supplement that helps livestock grow faster. Mitch randomly selects 20 piglets and adds the supplement to their daily food. He randomly selects another 20 piglets and feeds them the same food without the supplement. The piglets were raised in otherwise identical conditions. A month later, Mitch measures how much weight each piglet has gained. The mean for this one is 9.5, while the mean right here is 9. With supplement, 9.5. Without supplement, 9, just 9. Now, how much higher is the average for the treatment group? Then the average for the control group. I'm going to say that is 0.5. We do rudimentary math, so let's check if it's correct or erroneous. Let's go. Yeehaw! I know it worked. That's how I do it, guys. We hope you enjoyed. So we'll see you on part 1.2. Au revoir. Okay, guys, we're on our part 1.2. Let's go. After completing the experiment, Mitch wants to see that if the difference between the averages for the control and treatment groups was due to the treatment or not. To investigate this, he performs a significance test. The first step is to do a simulation using the data. He randomly reorganizes all of the data into two groups, A and B, each of size 20. In this simulation, Group A plays the role of the treatment group, and Group B plays the role of the control group. So, again, the mean for this one is 8.98 here, and this one is 9.46. 8.98 here and 9.46 there. So remember that the average for the treatment group was 0.5 higher than the average for the control group in the original experiment. So Mitch wants to compare this with the simulation results. So he subtracts the average for Group B from the average for Group A. What is this value? So just do rudimentary math. Then we get negative 0.48. So we're going to check if it is correct or erroneous. Let's go. Yeehaw! We know it worked. That's how you do it, guys. We hope you enjoyed. So see you on part 1.3. Au revoir. Okay, guys, this is part 1.3. After performing one simulation as the first step in his significance test, Mitch does 99 more. And for each simulation, he randomly reorganizes these subjects into two groups, A and B of size 20. In the simulations, Group A always plays the role of the treatment group, and Group B the role of the control group. After each simulation, he subtracts the average for Group B from the average for Group A. The distribution of the differences for all 100 simulations is shown in the histogram. So we're just going to be focusing. On this part right here, these three. So I'm going to say that since it's asking, it tells in the original experiment the average for the treatment group was 0.5 higher than the average for the control group. And what percentage of simulations is the average for Group A at least 0.5 higher than the average for Group B? I'm going to say that is 19%. You can see that's 12. This one is 6, and this one's just 1. So it's just 19. So we're going to check if it's correct or erroneous. I'm scared to do this, but let's go. Yeehaw! Phew! It worked! That's how you do it, guys. We hope you enjoyed. So we'll see you on part 1.4. Au revoir! Okay, so we're on part 1.4. Let's get to it. Mitch is now ready to complete his significance test. He uses his stimulations to determine whether the findings of his original experiment are significant at the 5% level. In the original experiment, the average for the treatment group was 0.5 higher than the average for the control group. Each simulation reorganized the subjects into two groups, A and B. Group A played the role of the treatment group, and Group B the role of the control group. Mitch found that in 19% of the simulations, the average for Group A was at least 0.5 higher than the average for Group B. Based on this result, are the findings of the experiment at the 5% level. So we're going to be asked about the 5% level here. So there's this thing I gotta tell you. It's called decision rule. If P is less than or equal to A, it works. If P is greater than A, it does not. So I'm going to say no, because the P value in this scenario is just 19%, and the alpha, or just in this scenario, A, is just 5%. So it's P, this one is A. So I'm going to just check if it's correct or erroneous. Let's go. Yeehaw! Wait, no, it worked! That's how you do it, guys. We hope you enjoyed. So we'll see you on part 2.1. Au revoir!